We are talking about finding limits algebraically. Yesterday was graphically and tabular. Today is algebraically. It's not tough. Okay, there's going to be some things we see that are a little bit different. And later on in calculus, and it's going to be a while. Like the last lesson I teach you for the year will make this process today easier as well. Okay, but we've got a while till that. And so we're going to do it with some the stuff I'm talking about is you need to understand more calculus. So we're not ready for that yet. But let's do some of this. If we are finding a limit algebraically, so if they give me an equation and I'm trying to find a limit, all we need to do is direct substitution. We're going to take our limit, our x value, and we are going to plug it in. All right, so for example, look at letter A. If I want to find the limit as x approaches 4, all I need to do is take the number 4 and I'm going to plug it in for x, direct substitution. 4 squared plus 2, what's my limit going to be? 18. 18. Some of us got to work on our squaring there, but yeah, it's 18. Done. It's nothing beyond that, because if you were to graph that shape, the graph would have a point at 18, which would make sense that that's going to be our limit. Okay, try B and C with your neighbor, see what you can do. Show me with your arm, what is 3 look like? What is 3? 3 looks like this. It's a horizontal line. It's just y equals 3. It doesn't say y equals, but it implies y equals, because we are talking about functions here. Y equals 3. So if I go to 43, what's your y value going to be? Still 3. There's none to plug in. So it's just 3. There's none to plug in. If it's a constant, it's going to be that value. The limit as x approaches 10 of just the function x. Show me with your fingers. What do you think limit's going to be? It's 10, because all we're doing, we're taking 10, we plug it in. It's this line right here. It's just the line y equals x. It's going to keep increasing. Every x value goes up, so is the y. It's 10. Make sense there? Letter D. Not any tougher. We'll take -3. We'll plug it in. -3 times -3 plus 1. -3 times -2. It's 6. Try letter E. Show me your fingers on E. Getting lots of 3s. None of this is tough. Hopefully you're getting good at this. If I plug in 2 on top, you're going to get 12. If I plug in 2 on bottom, I get 4. 12 divided by 4 is 3. Wonderful. Let's look at F. Plug in 1. What'd you get when you plug in 1 on top? When you plug in 1 on top, it's 1 minus 1, so it's 0. What happens when you plug 1 on bottom? You also get 0. You get 0 over 0. So what's that mean? That means this is a whole. Okay, this is not 0. That is not undefined. This right here is called indeterminate form. We don't know what the answer is. It's indeterminate. It's not divided by 0. It's not 0 on top. It's 0 on both. We don't know what the answer is. We have to do more in order to solve this problem. All right, so this right here, when we get this, it's a whole. So we're going to take our function. We are going to factor it. So x squared minus 1 on bottom, we are going to factor that into x minus 1, x plus 1. We factor, and then we should be able to cancel. Can I do that here? I got an x minus 1 here, x minus 1 there. That's going to cancel. And then I'm going to plug back in. Factor, cancel, plug back in. I'll ask you that a lot. Factor, cancel, plug back in. So we are then going to take the number 1, and we plug it in. Show me with your fingers. What is your answer here? Good. Nobody showed me 2. This isn't 2. My students all the time will say this is 2. No, it's 1 over 2. It's 1/2. Just a simple thing. Don't make it become 2. It's going to happen. Your first quiz you take over this, you're going to say that's 2. Don't do it. Questions there? All right. Try G and H real quick. Try G and H. We're going to find the answer here. So we're going to take 4. We plug it into the top. We take 4. We plug in the bottom. What happens? 0 over 0. If we get 0 over 0, it's indeterminate form. So Joseph, what are we going to do next? What'd you factor that top into? X minus 4, x plus 5, and on bottom it's x minus 4. If you get 0 over 0, you should be able to cancel. Can we do that here? factored, we canceled, then we're going to plug back in. We're going to take 4 and plug it in right there. 4 plus 5, my answer is 9. Everybody good on that one? Look at letter H. Show me with your fingers. What'd you get for H? Good. H, if I take 2 and I plug it in on top, it's 8 minus 1. I get 7. If I take 2 and plug it in on bottom, I get 2 minus 2. That's 0. 7 over 0. Do I need to factor, cancel, plug back in? No, because this is not indeterminate form. It is a form. It is exactly, we know exactly what the answer is. When we get a number over 0, it is undefined, and so my limit is going to be D, N, E. I'm going to not do I. I'm going to give you another problem if you already did I. Wonderful. Good for you. The limit as x approaches 2 of x minus 2 over 3x plus 7. Find that limit. Fingers. What'd you get for I? Easy. Take 2, plug it in. If I plug 2 right there, it's 2 minus 2, so it's 0. If I take 2 and plug it in there, I really don't care what the number is, but it is 13. 0 over 13. That is not indeterminate form because it's not 0 over 0. It is not undefined because 0 is not on bottom. 0 is on top. My answer is 0. Make sure you can be clear with that. Students struggle with 0, indeterminate, and undefined. Questions on direct substitution? It's easy. Just do it. Okay. Example 3. Now they're giving us piecewise functions. Calculus class loves piecewise functions. We're going to see it a lot. Be ready for it. So let's graph that. Graph that piecewise. Take a second with your neighbor. I taught you that back in August. Remember what to do. There's your piecewise function. If you've forgotten how to do it, we had a break line right here at 2. On the left side, I graphed x squared, so it's a parabola that stopped at 2. On the other side, I had the line 2x minus 1, so I started right here at negative 1, up 2 over 1, up 2 over 1, and then up 2 over 1. There's my graph like that. Everybody understand the picture? So if I want to find the limit as x approaches 3, which equation on that piecewise am I plugging into, top or bottom? Bottom. Morgan, why am I plugging into that bottom equation?
Because the top equation is less than or equal to 2, so it's never going to get to 3, but the bottom equation.
Yeah, the bottom equation, where does 3 fall? Well, 3 is greater than 2, so we're plugging into that bottom equation. So all we got to do is plug in. 2 times 3 minus 1. That's 6 minus 1. My answer is 5. If you look at your picture should back it up. At 3, oh yeah, I'm getting closer and closer to this y value of 5. Should make sense. Limit as x approaches 1. Show me your fingers. What'd you get for the limit as x approaches 1? Limit as x approaches 1 should be 1. Zach, which equation did you plug into? Why? Yeah, we're plugging 1 in. 1 is less than 2, so we're plugging into that top equation. And so all he's got to do is go 1 squared. It's 1. If I look at my picture over here, as I get closer and closer to 1, my y value is getting closer and closer to 1. Makes sense there? Then we've got C. The limit as x approaches 2. Which equation are we plugging into to find the limit as x approaches 2? Top one or bottom one? It is not top. It is both. Talk with your neighbor. Why is it going to be both? Somebody got a good answer for me. Why am I looking at both of them? Jacob? Good. Good. He said the 2 is included in the top equation. And so you want to say, oh, I'm just plugging into the top equation. But when we're finding limits, we don't care what happens at 2. It really doesn't matter that it's underlined at all. It doesn't need to be underlined. Instead, we have to look from the left and the right-hand side. On every other equation, like on this one, 3, a number just less than 3 and a number just right of 3, both fall into the same equation. So we didn't have to look at 2 equations. But because this one, the values to the left and the right fall into 2 different equations, we need to do both. So I need to find the limit as x approaches 2 from the left, and I need to find the limit as x approaches 2 from the right. That's what I need to do here. Okay, I'm writing it out in longhand, but we can understand what's going on. If I'm doing 2 from the left, I need to use the top equation, x squared. If I'm doing 2 from the right, I need to use the bottom equation because that's when x is greater than 2, 2x minus 1. And then I need to plug into both. So if I take 2 and plug it in here, I get 4. If I take 2 and I plug it in there, I get 3. is 4 equal to 3? No, 4 does not equal 3. So since the two limits are not equal to each other, then my answer is does not exist. And that should make sense if I go look at this picture. If I look at the line where x is 2, the left and the right sign are not approaching the same side. And so by looking at that graph, we can definitely tell that it's D and E. Makes sense on that one. You got two piecewise on the back. Try A and B on the back side for example 4. See what you can do. On letter A here, we're finding that piecewise function. We're finding the limit as x approaches -2. So, Scott, which equation are you plugging into if you're finding the limit as x approaches -2? Both equations. Why are you plugging into both equations? Because you want to know that. I need to know left and right. So I need to find the limit as x approaches -2 from the left and from the right. And so he really has to plug into both equations here. Show me with your, and we're trying to see, are they equal? Because if they're equal, I'm good. If they're not equal, it's D and E. And so make sure we're making that distinction. Show me with your fingers. What'd you get for your limit on part A? We're getting some 2's and some D and E's. Let's check. I'm taking -2. I'm plugging it in. So it's 1/2 times -2 plus 3. That's -1 plus 3. That's 2. If I plug in -2 here, it's -2 minus 1. It's -3. Is 2 equal to -3? No, doesn't work. Okay, see if I have my... Nope. I had a Desmos of that up. They're not anywhere close. You can graph the two lines. They're nowhere close to each other. It makes sense here that the limit does not exist. So this equation is D and E. Let's look at letter B. This one's a little bit different. We're finding the limit as x approaches 4. It's a piecewise. Which equation am I going to plug into? Show me with your fingers. First equation or second equation, 1 or 2. Which equation am I plugging into to find the limit as x approaches 4? We're doing a decent job here. The correct answer is just 1. Think about that for a second. Have a discussion with your neighbor because I want you to think about that. You only need the first equation. Come up with a reason for that. If I were to ask you what the value of 4 was, then I would want to plug in that bottom equation because it is 4. At 4, it's 7. But every other time on the entire graph, it's that top equation. So if I'm finding a limit, I don't care what happens at 4. I care what happens on the left and right of it. Well, how am I going to find that? By using that top equation. So that's what I'm using here. So if I'm finding the limit as x approaches 4, I'm plugging into this top equation where it's not equal to 4. It seems weird, but true. So 4 squared minus 16 over 4 minus 4. Guess what happens? Indeterminate, 0 over 0. So Jessica, what am I going to do then? What'd you factor that top into? X plus 4, x minus 4 over x minus 4. Then what? And then what? Factor, cancel, plug back in. We get 4 plus 4, we get 8. Done. Makes sense on that one. Let's get into a slightly more difficult one. Example 5. Eventually, we'll do this problem, and we can do it in some different ways. Okay, but for now, we're going to do it this way, and it's not that bad. Limit as x approaches 0 of that guy right there. What are we going to do to find the limit? Plug in 0. So if I plugged in 0 on top, I would get 1/3 minus 1/3 all over 0. What does that get me? Oh no, 0 over 0. Sad face. Because if I get 0 over 0, I've got to do more work. I don't know what my answer is. It's an indeterminate form. So I need to go from there. So before, every time we get 0 over 0, we factor, we cancel, we plug back in. There's no factoring to go on here. We need to simplify this funky fraction. Okay, it's a fraction over a fraction. We just need to get rid of some of that stuff because right now it's too complicated. We're going to try to simplify that out. And you've done these types of things before. It's just been a minute. So there are lots of good ways to do it. I'm going to do the way that I'm most comfortable with and see if you like it. And so what I'm going to do is get rid of this top denominator. Okay, I've got this x plus 3. I've got that 3 right there. I don't like having that. And so what could I multiply everything on top by so that there's no longer fractions on top? 3 and x plus 3. I'm going to multiply this by 3 and x plus 3. And if I multiply everything in the numerator by something, I have to multiply everything in the denominator by something. I have multiplied everything in the problem by 3 and x plus 3. And so what does that mean? It's like I'm multiplying by the same number on top and bottom, like 6 divided by 6. If I multiply everything by 6 over 6, is that changing my problem at all? I'm just multiplying by 1, but it's going to rewrite it in a different fashion. Okay, so let's look at this. If I take this top fraction and I multiply by 3 times x plus 3 times 1 over x plus 3, what can happen? X plus 3s, I'm left with just 3. Okay, and then the same thing here. Those 3's are going to cancel. Finish that problem. Be careful there with that minus sign. Show me with your fingers. What'd you get? All right, we're not there yet. Let's try it anyways. What is this going to become on top? This is the place you got to be careful with here. You could write this as minus x plus 3, but it is minus that whole thing because it's being multiplied together. So I'm going to write that as minus x minus 3. Everybody understand that part? On bottom, I am multiplying 3x times that, so it's 3x squared, and then plus 3x. Everybody clear on that first part? We didn't. Oh, yeah, that's what I said. 9x. My bad. Everybody good to that point? If we plug in 0, or if we plug in 0 here, what's going to happen? I still get indeterminate form, so I didn't do anything yet because I still got to clean this up. And so on top, well, I've got a 3 and a negative 3. Those two things are going to cancel. So now I'm left with negative x over 3x squared plus 9x, which still is in indeterminate form. But we talk about factor, cancel, plug back in. We didn't factor here. We simplified, and then we have to cancel, because if we don't cancel, we're still going to have that hole in this problem. What can I do to cancel here, Markel? Take an x out of everything, right? Every single thing in this problem has an x in it. Everybody agree with me on that? And so I'm going to cancel an x out of everything. And so this is going to become negative 1. I'm taking an x out of the top. I'm taking an x out of this, so it's just 3x. And I'm taking an x out of this, so it's just plus 9. We simplified, then we canceled. We took an x out of everything, and now we're going to plug back in. So if I plug in back there at 0, my answer is negative 1/9. Make sense on that one? A little bit different, but you can handle it. We got rid of the denominators and then worked from there. Example 6, we're going to do this more later on, but I'm just going to show it to you. Right now it looks kind of scary. It is kind of scary, but don't be too frightened. I'm going to plug 0 in. I'm going to save you the heartbreak here. Guess what happens when you plug in 0? It's indeterminate, 0 over 0. And so we need to factor, or in other words, we're going to simplify, cancel, and then plug back in. So if I look at this thing right here, 4x plus h squared, we're finding the limit as h approaches 0. And this is something we're going to do a lot later on. So pay attention to this. I'm going to kind of clean this up on top. Okay, this is easy. That's just going to be negative 3x minus 3h plus 2 minus 4x squared plus 3x minus 2. I didn't really have to do anything there. But this first part's ugly. What am I going to have to do to take x plus h and square it? Foil it. And so if I foil that, I'm just going to write it right here. That is x squared plus 2xh plus h squared. If you don't believe me, foil it. I would recommend memorizing that because later on you don't want to foil that every time. What else do I need to do with that x squared plus 2xh plus h squared? I got a 4 in front. I got to distribute that 4 in. And so my value here is 4x squared plus 8xh plus 4h squared. That is all over h. We kind of just multiplied out there, which was annoying, but we can do that. Try to simplify, factor, cancel, plug back in. See if you can go from there. Your answer looks a little bit different than every other answer we've gotten so far. So anything that could cancel here, Natalie, what'd you get rid of here? 4x squared. She's got a 4x squared here, negative 4x squared. Anything else? negative 3x and a positive 3x. Good. Anything else? 2 and a negative 2. Everybody see what she just did there? We're going to do these problems a lot later on. Notice that everything that canceled didn't have an h with it. Everything that's now left, 8xh plus 4h squared minus 3h, this, and that, everything has an h in it because it's all divided by h. So now what can I do? Take an h out of everything. And so now I'm going to be left with 8x plus 4h minus 3. That is not the answer to the question because we are trying to find the limit as what? H approaches 0. So we're going to take this 0. We go and plug it in. That thing's going to go away because it's 4 times 0. My answer is 8x minus 3. That is just more an application. We will do that again later on. So if right now you're looking at that and you're like, I don't know. Cool. Don't worry about it. We'll do it again later on. Questions on 6? Last thing, just really quickly. I know we talked about it yesterday. I want you to see it again. Okay, this is a graph you have to know in order to do well. Calculus and absolute values don't mix. And so when we see absolute values, we need to understand what the graph is. You need to be able to graph the absolute value of x minus 3, x minus 3. Okay, if you don't know, plug in numbers. If I plug in 0, it's 3 divided by negative 3. It'd be negative 1. Okay, if I plugged in 1, it'd be 2 over negative 2. It would be negative 1. Or in other words, this graph is going to look like this every time. You're going to have one line at positive 1. You're going to have one line at negative 1. Whatever number is being added or subtracted, that's where the break is going to happen. So this graph is going to look like this. That to the right of 3, I'm at positive 1. To the left of 3, I'm going to be at negative 1. And again, you can do that by just plugging in numbers, but you need to know how to do that. So if I'm asking you the question, what is the limit of this g equation at 3, what's my number going to be? It's D and E, because there's a break in that graph with a giant jump in. So if I'm trying to graph 2x over absolute value of x, where is that break going to happen? When is it going to be an indeterminate form? 0. If I plugged in 0, I would get 0 over 0, so it's indeterminate form. What's going to be different, do you think, on the second one than the first one? It's times 2. So if I put a 2 out in front, it's going to stretch it. And so this graph is just going to look like this now. Instead of at 1 and negative 1, I'm at 2 and negative 2. The limit as x approaches 0, oh, that's still 0. I'm sorry, it's still D and E because there's a giant jump in this graph. It's indeterminate form, but it's a little bit different. We couldn't have found that in any other way than to understand the graph.